Hey, what's up guys, and welcome to this video. In this video we're going to talk about the connected rates of change. Okay, and know that the rate of change actually is the speed in which a variable changes over a specific period of time. Okay, and it's often used when speaking about mountain, and can generally be expressed by as the ratio between a change in a variable relative to a corresponding change in another. Okay, so and this is and graphically the rate of change is represented by the slope of a line. You know, the slope, gradient, and everything of the line. Okay. um of course, to solve like this problem we got here, we will be using the chain rule to do that. You know, solving the rate of change problem, we usually use the chain rule. Okay, so in this exercise right here, uh, we're we're given uh, as a volume, of a sphere, and the volume is given in centimeter cube, which is equal to 4/3 pi r to the power 3 to the 3, and r is given in centimeter. Okay, and they say that V increases at the rate of 1.5 centimeter cube per second. So we need to find the rate of increase of r with respect to the time when r equals to 2. So before solving the problem, let me put an answer here. Go back again. Okay, let me just put answer here. Before solving the problem, we need to integrate, to identify what we get and what we don't. Okay, this saying here, the volume of a sphere is given by V, and this is V. Okay, that's a volume. So we have the volume. It is equal to 4/3 pi r to the power of 3, and this is given in centimeter cube. Okay, also we are given the rate of change of V. V increases. This is the here, prior to the time. So that's the rate of change. It means that the rate of change is, it means that we have a dv, that's a dv, prior to the time, that's what it says here, and it's equal to 1.5 centimeter cube per second. Okay, and this here, to make it clear, we can write it this way, because not to mess it up, we need to do this way. Okay, so we're gonna say that this it is centimeter. Hold on, it is centimeter cube per second, per 1 second. Actually, we have 1.5 centimeter cube, and then we got a second. This is how we wrote it here. We got a volume and a second under it. Okay, so that's it. What we got. Okay, so and here we're looking for dr prior to the time with respect to the time. So we're looking for dr divided by dt. Okay, that's what we're looking for. Okay, and now the general formula, that's what we know. General formula in a connected rates of change, we know that dv with respect to r equals to dv with respect to the time times dt with respect to dr. Okay, that's what we know. The general formula when we work with the connected rate of change. So the derivative of v with respect to r, we don't have it, but we can find it, right? We can find it by derivating this one here, by derivating this one here, okay, with respect to r. So we're gonna have it. Okay, then let's go continue, and this one here we already have it. It's 1.5. Okay, and it remains. So let us do derivate this one here. So we're gonna say let's continue the same color. We're gonna derive. Hold on. Okay, we're gonna make a derivative of v with respect to r, and this is actually um, v is here with a 4/3, right? uh, pi, those are all constant, and this is what we're going to derive, okay? And the derivative of 3, r to the power 3 equals to 3 times r to the power of 2. All right, okay, now the 3 will cancel out, okay, and our result here will be 4 pi r to the 2. Okay, so now we got almost everything. We can just replace it by this one here, and what we're looking for still be that one there. Okay, so we can say that this means that 4 pi r to the 2 equals to, this is your 1.5, that would be 1.5, okay, and times dt by dr. And here we can multiply by 1.5 on both sides, 1.5 here, and here by 1.5, or divided by 1.5, sorry, because it is at the numerator, so it has to be at the denominator now. Okay, let me just take this back. Okay, that's what I wanted before. So we can divide by 1.5 here, and here by 1.5. Okay, so this is going to give us 4 pi r to the 2 divided by 1.5, okay, equals to dt by dr. Alright, now I can multiply both sides of this fraction by -1. Okay, this means that I'm just gonna take the reverse of what I got now. I mean both sides. It means that this is gonna turn up and down. The denominator is gonna be at the numerator and vice versa. Okay, so that's gonna give us 1.5 divided by 4 pi r to the 2 equals to dr prior to dt, and this is what we're looking for, because we were looking for dr, with respect to the time. That's what we got. Okay, so now we almost done. Remember, I had, with the exercise said that r will equals to 2, so I'm going to just replace r equals 2. Just want to go again. Okay, r equals 2 here inside, right, in the exercise here, and that's going to give me so 1.5 divided by 4 pi 2 to the 2 equals to dr with respect to dt. Okay, and this is going to give me, remember, if you write a 1.5, remember this word, I'm going to put the unit behind, okay, not to mess up everything. So then I got here, this is here centimeter to the 2, okay. Then I have 4 pi, or let me put 16 pi already. Okay, I got here 16 pi, okay. And talking about the unit, we had here, let me put a different color for the unit. We had here, this has been, remember this one here, we said it was centimeter to the 3rd centimeter cube per second. So it's going to be centimeter cube per second, okay, divided by, and this one here is, that was the radius here, and we squared it, so centimeter square. So we divide it by centimeter square. That's how it looks like. Okay, and then this whole thing will be equal to dr with respect to dt. Okay, this is the division, but let me just continue and say and do something. So I'm going to say that it's 1.5. I can even give you the calculator already. Hold on. So this is going to be 0. 0.0 298. Okay, so what about the units now? We have in here centimeter cube per second. That was for this one here, divided by, and you know when you got two division, okay, you get to turn, you can turn them into multiplication by just using the reverse of this other fraction here. Okay, so then I'm going to say that it's times 1 divided by centimeter squared. Okay, and that's equals to dr dt dr, yeah, of course, with respect to t. And now for the time, and now we can, you know, just let to the power here, and there remains 1 here. Okay, so we will have our final result looking like this. Therefore, dr with respect to dt will be equal to 0.0298. We cut 2 power here, it remains 1 centimeter, so it's going to be centimeter per second. This is what remains here. Okay, and this is our final result. Okay, thank you guys for watching, and until next time, bye bye.